I want to welcome you to another new week. Of course, today we're going to start chapter 5 that we'll call complex regressors. But before I get started, I quickly want to make an announcement. I observed that I think one of two students turned in a wrong assignment, like maybe assignment 3 for assignment 2. So please make sure you read the post-assignment comments that I left so that you can quickly correct that. Assignment 2 should go into assignment 2 ports, and assignment 3 should go into assignment 3 ports. So make sure you turn in your assignment to the appropriate ports. So I will advise you check the post-assignment comments that I left. Okay, so I want to go into chapter 5. We study chapter 5. Uh, this is on complex regressors. What do we mean by complex regressors? And of course, before, I think I've been able to justify why at times we may need more than one predator in our model. Of course, the moment you start having more than one predator, or you have the combination of predator in your model, whether it's this in a linear form or non-linear form, or in terms of interaction and stuff like that. That's exactly what we mean by complex regressor. So in the outline today, I'm actually uh, going to walk us through situations where I only have categorical predator in my model, and how can we interpret that? Number one, how can we set up our model with only categorical or predator? How can we set up our model when we have the combination of categorical predator and continuous predator? And after setting that up, okay, how do we do estimation? And, you know, what are we going to put, what are the necessary machinery we're going to put in place to ensure that, we're able to estimate the parameters in the model. And after we've done with that, and we also have a way to make an interpretation, because at the end of the day, we're gonna end up interpreting our model. I'm gonna start with situation whereby you have one predator in your model, and that predator is categorical. So take a look at this. You know, uh, you know, uh, if I have for instance, let me start with two predator. If I'm looking at the effect of sex and race on a particular response, and the sex here, I'm talking about male and female, and the race, I got different kind of races. And if you take a look at the two variables here, they are categorical. I'm going to say that again. Right now, the example one is talking about having two categorical variables, two categorical predators, explaining why. Why could be anything. Why is response? And of course, let's say we've already estimated the regression parameters, and this is what we have. Of course, uh, in your model, you're not going to specify uh, all the levels of categorical variable. For instance, for sex, we're going to only specify one level out of the two. As you can, as you can see here, you can see sex female arrow. It means arrow has automatically coded female as 1. That's why it's appearing. And it has coded male as 0. The same thing applicable to race. Okay, even if we have different categories of race, like more than 2 levels, the one that is appearing here is what arrow coded as 1, and the other is going to be 0. But let me tell you this, the one arrow as coded, I mean our software has coded as 1, that doesn't mean that level of categorical variable has a superior numerical advantage. No, it's just for labeling. I'm going to say that again. The fact that you are seeing sex female or you're seeing race black does not really means they have numerical advantage over the other levels. Okay, this arrow can hold whichever level as one and whichever level as zero. But the only takeaway here is the one that is not appearing in the output is the one that is being referenced. If you want to have a comparison of what is showing, you're actually going to compare that with the one that was referenced. So the one that was referenced is actually nested in the intercept. Okay, I want to get information. Now, if I if I'm actually if you take a look at, I want to explain that now. Okay, it's going to be the difference between the mean of females and the means of males. You can see you're not seeing any males, right? That males is being referenced. So when you are working with a categorical predator, you actually need one at a reference level, and the one that appears where you're going to be comparing with the reference level. So the same thing applicable to race black. Okay, the estimate that you actually seeing here, that is what is represent. Okay, that's the estimate for race black is, studying all the difference between the mean of blacks and the mean of whites. Situation where maybe we only have two categories, or the other one is black and the other one is white. Okay, I'm actually going to move. I just talk about situation with two categorical predator, each having two levels. And of course, in our model specification, we're not going to specify all levels. If you specify all levels, it's actually we're going to run into a problem. And that very problem is called a dummy variable trap. We don't want to get into a dummy variable trap. And that is the reason why if I have k levels of a particular categorical predator, what I'm going to report is k minus 1 levels. Okay, I want to move right now. I want to move in a situation where, in example one, I only consider two categorical predator, each with two levels. What of in a situation where one of the categorical predator has more than two levels? There's possibility, the levels of one categorical predator may be different from others. I want us to look into this example. We actually we have two categorical predator. Okay. Let me first start with one. We have one categorical predator here, and we have this categorical predator has four levels. We're talking about geographical location in the United States. According to the U.S. Census Bureau of Geographical Location. Okay, when you take a look at, we have the Northwest, you have the Northeast, you have the West. There's a particular, if you take a look at the model specification now, we're not going to specify all the levels of categorical predator in order not to fall into a dummy variable trap. Now, there's a particular location missing that we call South. And that very South is being referenced. Okay. Now here we're trying to look at the effect of location on salary. Okay. Now we'll talk about the Midwest. We got states in the Midwest, including Minnesota, Iowa, Michigan, Ohio, Illinois, and so on like that. Okay. I know for those of you that are aspiring to work in the future and you are in the United States, and you may actually put into constant every other effect, every other factor that could affect salary if you are considering location. Okay, so the model, if you take a look at example two, okay, this is an estimated mean function where we're looking at effects of categorical predator location and salary. And if you take a look at what I have, like I said, we got 4 levels. We're not going to report 4, we're going to report 3 out of 4. And the one that was not reported is actually being referenced. That doesn't mean the one that was not reported has maybe inferior numerical advantage over the other. No, it's not like that. That's not what we mean. Talking about our labeling, and of course, the South is actually being used as a reference. So if I'm going to take a decision, if I'm going to interpret or any of the other location apart from the one that is referenced, I'm going to be comparing. Okay, now we've estimated based on the model specified, we've estimated this. I want us to have a sense of, understanding of what each of the estimated regression parameter actually is saying. Now, I told you the other time, you're actually going to start with the intercepts, okay? Because I'm only considering one predator with levels. The 96.6 is actually has to do with the South. The South is coded 0. Don't forget. When you want to go by technical interpretation of y-intercept, you normally say the values of y when s equal to 0. So here, okay, we coded south as 0. Now, when we coded south as 0, if you take a look at what I'm trying to say now, I'm trying to say that is the average salary for the south. Average salary for the South here, I'm not considering any other region or location in the US other than the South. And that's why you see other location I put is 0. Is there any question about that? Any question? Okay, now I'm actually want to move right now. Okay. If I want to interpret this, please pay attention. I'm on the Midwest. And when I go with the Midwest, it's 2.94. Okay. And that was a negative. Okay. If I really want to estimate, okay, the average salary for Midwest, okay, now the negative 2.94 is just trying to tell us that somebody in the Midwest will earn $2.94 less because of the negative. Now, take a look at this. Okay, why am I doing this? I'm saying, oh, uh, Midwest equal to 1. Don't forget, I'm using 1 and 0. When Midwest equal to 1, okay, every other location is actually going to be 0. I'm focusing on the Midwest. Okay, now what is going to happen if I really want to estimate the average salary in the Midwest? It's going to be 96.6 minus 2.4. Is there any question about that? Okay, if I want to do the same about the Northeast, oh my God, this is giving me information. Oh, this is going to make some people to rush to the Northeast. Because you know why? 10.25 above the 96.6. Okay. Talk about Northeast, talking about the New York, Pennsylvania, and the like. Okay. So, with that, I'm actually adding, and that will be the highest. If I want to talk about the West, okay, if I want to talk about the West, okay, it's going to be, take a look at that. Then I'm going to subtract that from that, which is what you're seeing here, because you got to put into consideration the sign, okay? That is for the West, okay? But you know what? All what I've been computing all this why, okay, though, that is the average salary for each region. Okay. But if I now want to interpret this one directly, okay, I want to interpret that guy directly. I want to interpret that guy directly. I want to interpret that guy directly. How is that going to be interpreted? Okay. Now, when I want to focus on the Midwest, I will be comparing each of that with the South that was referenced. And that was why I said, having a negative 2.94, I said that is the difference in the average salary between the South and the Midwest. If I'm focusing on on this one. Then I want to compare northeast location with the south that I referenced. And that was why you see this 10.25 difference in the average salaries between the south and the northeast. And finally, if I want to talk about the west, okay, I want to interpret this. I'm also going to say the same between the south and the west. So the particular level of predator that you reference is what you're going to be comparing other level with. Any question? Go ahead. Yeah. Okay, so if you want to do that, you will reprogram that to say that you're no longer using south. This data assume the arrow is referencing south. You can reference any level of the categorical response. Does that make sense? So all we just need is you need in one of the level, you need one that would be in a reference category that you're going to be comparing others with. So the essence of having a categorical predator is for comparison. Does that make sense? Okay. Now I want to move. That's a good question. Now I want to move right now. I want us to move to an extended. Now this is becoming a complex now. You want to see the complex regressor coming in addition to the effect of location on salary. I also want to maybe uh you you want to work for public company or you want to work for private and you now want to also incorporate the effect of working in a public and private into the model. If you take a look at what I have now, please pay attention. Okay, take a look at what I have now. I got two categorical predator. One is location and the other one is whether it's private, whether you want to work with private company or public. But here I can see public. In the model, it means R as automatically reference private. So private is zero here. So there are two things that are zero here. Private, R label private as zero. R also label south in the location as zero. Does that make sense? Okay. Now, based on what I've done before, I can recalculate. Please pay attention. Take a look at this. That is interpretation if I want to interpret this. Don't forget, I got two, I got two categorical predator, okay? Uh, arrow reference in the location, arrow reference out, that is a label south as zero, and it label private as zero as well. 99.5 says then would be the salary of somebody in the south and it's actually working for private company or private institution. Does that make sense? Okay. Now, where you want to continue, okay? For instance, if you take a look at, you want to focus on this, you want to focus on Midwest. There are two things. You may want to focus on Midwest. The Midwest is, you want to focus on Midwest, and at the same time, Midwest, is it Midwest private or Midwest public? Okay. You talk about Midwest private, that is that. Okay. Please pay attention. Okay. So I'm actually going to subtract that from that. Okay. So which means if we are both working in a private or institution, okay, and we're in different location, we're having different salary. Can you see that? That's what that means. Okay. So if you continue, is there anyone here who doesn't understand this? Is there anyone who doesn't understand that? Do not hide your feeling. Is there anyone? You can all hear me, right? Everybody can hear me? Okay. Now, you all get that, right? Okay. I'm moving. I want to move into, all this why we've been focusing. I remember when I started with two categorical variable, each having two levels. Then I moved into two categorical variable. One has four levels. Oh, sorry. I moved to just one categorical variable with four levels in example two. In example three, I move to two categorical variable, one having 4 levels and the other one having 2 levels. Now, all the way from example 1 to example 3, I have not considered a continuous predator. I've only been considering categorical predator. I think I've walked you through how to interpret that. Now, you know what I want us to talk about? I want us to use United Nations data. Okay. I want us to work with regression with both categorical and continuous predator. Let's have an example. Now, when you take a look at this data, okay, these data actually talk about the national health, welfare and education statistics for 210 places. Some of them are countries and some of them they are not independent. Okay, so I just wanted to take note of that. Now, the data frame have 237 observations on the following 32 variables. There's a lot of variables, but we do not have time to incorporate all variables. But we are interested in number one, we're interested in group. Okay, one of the categorical predator is going to be group. And what do we mean by group? Okay, we actually have three different group of countries. Okay, the one in the OECD, the developed countries. Okay, they are in one category, and others in one category, and Africa in another category. So it's like we're having 3 categories. Okay, that group is one of the factors that we want to consider. And of course, fertility, the number of children per woman, PPGDP, per capita gross domestic product, the female life expectancy years, and of course the percentage of ban. Okay, but we have a lot of data here. Now it depends on what we want to work on. Okay, what if I decide actually I want to try to investigate what are the factors that determine the female life expectancy. Okay, now the female life expectancy. Okay, women are doing a lot of great job, including my mom and my wife, including all women in the world. They're doing great job. Okay, now let's say for instance, I actually want to look into uh, the effect of region, the effect of growth on life expectancy. I need you to pay attention. Okay, equation 5.2. I only want to look at the effect of a group for now, effect of one categorical, group. Okay, effect of a group. Okay, on the life expectancy, and we got 3 levels in this group: the OECD, developed countries, Africa, and others. But let me tell you this. We're in the module specification, we're not going to specify for the 3 groups. We're going to run into dummy variable trap. We're going to tear out whichever one you want to reference. Right now, I want to reference OECD, or countries in the OECD, which means I want to be comparing other group like Africa, like others. I want to be comparing them with the developed countries. Does that make sense? Okay, if you equation 5.2 right now, you can see U2 and the U3. Okay, so now what if I want to talk about the intercept in this module? The intercept in this module is when I put U2 and U3 to be 0. That is when I said others and Africa equal to 0. Okay, I want to talk about what would be the estimated average life expectancy for women in the developed countries. Then I'm actually talking about this guy. Can you see that? That is the average life expectancy in for women in the developed countries. That will be beta on. There I put a mu2 mu3 to be equal to 0. Now, if I actually want to consider the second group is others. Okay, which means I want to say let mu2 equal, where u2 equal to 1. Okay, in the model, if you take a look at the general model, okay, we have a beta node, we have a beta 2. I'm plugging U2, I'm plugging one for U2 because I'm focusing on the order, okay? The domain for the dummy for others is U2, the dummy for OECD is U1, the dummy for Africa is U3. Okay, now what are you gonna see? What you actually gonna see is this guy. Just pay attention. For the beta nut, that is the average life expectancy for women in the OECD. Okay. In the second one, I'm focusing on the average life expectancy for others. Okay. Now, it now depends on the sign of the beta 2. When beta 2 is negative, the life expectancy in others will be less than the mean life expectancy in the OECD. So that would depend on beta 2. Now, if I now want to talk about Africa now, okay, I'm actually going to say U3. Okay, I'm going to plug in every, we take a look at that. Now, look at, I need you to pay attention now. This guy, and this guy. Look at the three of them. The first one is actually the mean, okay, for the reference group. The OECD is being referenced. The second one is actually the mean for others. And the third one is actually the mean for Africa. Is there any question on this? Let me tell you this. If you get the specification of the mean function wrong, then every other thing you're going to be doing will be wrong. Okay, now we want to, now how are you going to do the labeling? You know, you asked a question the other time. How are you going to do the labeling? You would do the labeling yourself. You can do the labeling yourself. Look at this. You know, I'm trying to say, okay, where you see 0, okay, you can say I got U1, U2, U3. Now, if you look at a country like Afghanistan, you know, when you take a look at let's talk about Afghanistan for instance. Okay, now U2, this guy is OECD. Okay, then what this guy is trying to say, Afghanistan is under orders. Does that make sense? Orders. Okay, so Afghanistan is not Africa. Africa is U3. That is why it is 0 here. Can you see that? Okay, you can do the labeling yourself, like whichever one you want to put in a reference category. Okay, now I just wanted to take note of that. But let me tell you this: having this information, and you can see the OECD member, one of the OECD member, Australia and Austria. Can you see that? Okay, U1, where U1 equal to 1. Can you see? Others will be 0, including Africa. So here I'm considering Australia and Austria. They are members of the OECD. Does that make sense? Okay, now uh if I want to behave like John Turkey in 1970, John Turkey said, can we have a detective work? Before going into differential statistics now, can we just try to understand the distribution of the response? For instance, if I want to understand what is the response variable here, the life expectancy, can I have a way to look at the distribution of the life expectancy in each of these groups? What am I going to do? Then I'm going to generate a bus plot. Please pay attention. We don't just do what we do. There's a reason why we do what we do. You know here, the first plot will give me an opportunity to compare the distribution, okay, of the life expectancy for women across groups. Now here, I'm actually going to have opportunity to see that is, in the OECD, okay, they have the higher life expectancy. Look at that. Can you see the box plot? Okay, they have a higher, followed by the other, and the African is the lowest. Oh, I don't want to be emotional. It's true because I'm from Africa. I know women suffer a lot in Africa, and I'm actually going to say, uh, I wish all women in Africa and everywhere in the world, long life. It's not easy to be a woman. Okay, it's not also easy to be a man. It's not easy. So now, so wait, so this is confirming that. And you know what? If you take a look at the box plots, this is also giving us there could be some outliers. If you look at the order, country like Nauru, Afghanistan, can you see that? Okay, having an outlier, there's possibility, according to Camp in 1982, a data that is not consistent with the rest. Of course, uh, Afghanistan is in, of course, here, then Japan and Turkey in there. So the first graph here is just giving you a picture that, okay, can we have a way the life expectancy is being distributed, when you look across group. Okay. Now, when you take a look at the second one, the second one is what we call effect plots. Okay. And if you take a look at the movement, if I move from the OECD, look at that. Okay. This is confirming the OECD is consistently the highest, like when it comes to life expectancy, and that is moving down. You can see that. And the lowest is Africa. And of course, uh, I have a confidence interval, constructed for them, for each of the group. And let me tell you this, the fact that the confidence interval, there's no overlapping between groups, that shows, okay, they are statistically, the difference between the three groups in terms of the life expectancy is statistically significant. Does that make sense? Okay, I'm going to move right now. I want to move to something. I want to move now. Uh, I'm still on the group. I'm focusing on the group. And you know what? I run a regression using the United Nations data. Okay, let me use this opportunity to tell you that when I give assignment and I wanted to use data, okay, check the instructor resources on Canvas. Okay, all the data that we're going to use, they are there, including the how material. What I'm just doing every week is just to tell my TA, okay, this week we're going to focus on this chapter. You can, if I were you, you can go through those material even before the lab. Does that make sense? Okay, right now, I try to look at the effect of group on the life expectancy. Okay, and there's something that I'm seeing here. You can see that? I can see group order, group Africa, then group OECD is being referenced. Does that make sense? We're always going to reference. You can decide to choose the one you want to reference. That's no problem. Okay. So, of course, this is giving me on average that the estimated life expectancy in the OECD for women is this. Is 1 second. Is 82 point. Can you see that? Okay. And the group order has a lower life expectancy. Why the largest difference can be seen with the women in Africa. Can you see that now? Negative 22 points. That is the largest differential. Okay. And if you come to the p-value, they are all statistically significant. So which means, we don't just interpret the estimate. I'm only going to look at the estimate to interpret the estimate when I realize the p-value is actually less than 0.05 level of significance. Take a look at that. But let me tell you this, or whatever I'm doing here, if you take a look at this guy, on average, the actual life expectancies deviate about 6.3 years. That is the residual standard error. That's what the residual standard error is telling me. Because our model is not going to give us the exacts. A model does not give exact characterization of reality. And that's why you're always going to have a residual standard error. Okay. And of course, if you want to look at how the predator you use, how the model explain how much percentage variation in the life expectancy, this was able to explain the group was able to explain, I think about 62%. I'm actually moving. Now, this is the table. Okay, this is the table. Okay, that is the table. Okay, for different groups. And of course, what if I ask you to generate what is the estimated life expectancy? It's calculated here. Is there anyone doesn't understand how I figured that out? Of course, the countries in the OECD, the life expectancy of women with around on average 82.45. Okay, followed by others, and Africa will be the lowest. Is there any question on this? Okay, if there's no question, okay, like I said, the African share, you know, the difference, the large difference here. Okay, now I'm actually moving. For instance, if I want to reparameterize my estimates, I really want to compare a contrast. I want to compare the difference between two groups, and I want to estimate that. What am I going to do? I want to come up with, for instance, let's say, look at this. Beta 2 minus beta 3 means I want to estimate the difference between two groups. I also want to have a standard error associated with that because the difference between that two groups is an estimate. Then I should have a standard error in case I want to conduct a statistical inference. Okay, now the B2 and the B3 is others and Africa. The group order and group Africa. Okay, I want to statistically, I want to see, here, the table here does not, it's not really telling us, because here, the table here only enable us to compare others and Africa with the OECD. For instance, if I want to compare, if I decide that I want to compare uh, others and Africa, okay, now I'm going to go, we call that comparison of level means. I'm going to do beta 2 minus beta 3. Of course, I've already estimated. I have my beta 2. Okay, I have my beta 3. Can you see that? I have them already estimated. I'm only going to subtract them. And when I subtract them, I also need the standard error associated with my estimate. And how do we find the standard error associated with my estimate? Please pay attention. Okay, I'm actually going to use this, which we call the standard error of that comparison given S. And let me tell you, the sigma cap is the residual standard error. Then inside the square root, okay, because of this is 2, I need the variance for that. Variance in that class. Variance in others, okay, C22, the variance in other, C33, the variance in Africa, C23, then the covariance, because I'm considering 2 different groups. And now am I going to get my covariance matrix? Okay, now I want to take you back. Okay, here, you do MOD, you run that, right? If you want to get your variance covariance matrix, you're going to write CVOV, you're going to write this. Can you see that? You want to extract the variance covariance matrix, and that is going to automatically give you this 3 by 3. That will give you that. And the moment you have that, please pay attention. Okay, now these are the variances. Okay, this guy is the variance of the beta naught, the variance of the beta 1, the variance of the other one. Now, here I'm actually using, I'm actually here in this model. I think this is what I'm trying